Okay, so now we're doing question 5. So question 5 says, Jeffrey and Jace climbed a tree and each threw a stone up in the air at the same time. The graph represents the height of a stone t seconds after it was tossed up by Jeffrey. So Jeffrey is the graphs. So that's one thing I want to clarify to make sure we all understand. So this is Jeffrey's. And then the function f given by f of t equals negative 16t minus 4 times the quantity t minus 3 represents the height of a stone t seconds after it was thrown by Jace. So Jace is the function down here. And then both functions, the height is measured in feet. So for question A, it says who threw it from the highest spot on the tree. So looking at Jeffrey's, we can just look at the graph and we're actually looking at where he threw it at 0 seconds. This means that he was up in the tree and that was the exact second that he threw it. So he threw it about 16 feet, 16, 17 feet, about 16 feet. Now for Jace, it's a little more complicated because we have the factored form here. And in order to find the y-intercept, to figure out how high Jace was in the tree, we need to write this factored form in the standard form and look at the C value. So really, we only care about this part of it. So really, I only care about multiplying that -4 and that -3. When I multiply -4 times -3, I get a positive 12. So that means that Jace must have been 12 feet up in the air. So Jeffrey is the one who threw it from the highest spot because he threw it from about 16 feet. Then looking at question 2, whose stone hit the water first? And when did that happen? So if we look over here at Jeffrey's graph, we can see when his hits the water, that means he no longer is in the air and it has a height of 0. So basically we're looking at the x-intercept. So right here, and his is about maybe like 3.25, 3.3. So Jeffrey is about 3.3 seconds, somewhere in that range. 3.25, 3.3. So now for Jace's, again, we only have the function, so we need to figure out how to find the x-intercepts. Remember, to find the x-intercepts from the factored form, we set them both equal to 0. So I'm going to set this equal to 0 and solve, and this equal to 0 and solve. So I'm going to do that over here. Negative 16t minus 4 equals 0. So when I'm solving this, I can't just do the positive 4. I can't just take the opposite because I have a coefficient here. When I have a coefficient, I actually need to like think back to algebra 1 and solve this. So I need to add 4 to both sides. So that will cancel that out and I'll get negative 16t equals 4 because 0 plus 4 is 4. And then the next step that I need to do is divide both sides by negative 16. And when I do that, I'm going to get t equals negative 1/4. And that means that this x-intercept is actually before, like if you pictured it on the graph that Jeffrey's is, this is before he actually threw it. So that's not the x-intercept we're talking about. And that x-intercept really wouldn't make sense in terms of throwing the stone because it didn't shoot up into the air with 1/4 of a second. So that one doesn't really make sense for this one. So then we want to look at the other x-intercept, and that's t minus 3. So I'm going to do that one over here. So t minus 3 equals 0. And this one we can just do the opposite because when we're adding 3 to both sides and solving for 0, it equals a positive 3. So that means his would be here, which that one does make sense. So that means that Jace's stone must have hit the ground at 3 seconds. So Jace's hit the stone at 3 seconds. So therefore his happened first and it was at 3 seconds. All right, then for part C, it asks for the maximum height of each throw. So for Jeffrey's, we're looking at the vertex. So the vertex is happening probably about here, which is maybe 36 feet because that's the highest point. So Jeffrey's is about 36. I'm going to say approximately 36 feet in the air. And now we need to find Jace's using, again, we have the factored form to do that. So in order to find the vertex of the factor form, we need to find the exact middle of his 2 x-intercepts. So we just found the 2 x-intercepts. We have negative 1/4 as one of his x-intercepts, and we have this 3 over here as the other one. So we're going to add those 2 up, and then we're going to divide by 2. Just because there's a calculator, or just because I have a calculator and there's a fraction involved, I'm going to share my calculator screen, and we're going to do it in here. So I'm going to do negative 1/4 3 to it because those are my two x-intercepts, and then I'm gonna divide it by 2 so I can find the exact middle. So 1.375 is the exact middle of those two. So 1.375. So that's the seconds of when Jace's rock got to its highest point. So somewhere in here is where he got to his highest point. But again, we don't know how high it is. So to figure out how high it is, I need to plug that 1.375 in for this T and in for this T. So that way I can find the height of it. So going back to my calculator, let's go back to my calculator. I'm going to plug that 1.375 in for the T. So I'm going to type it in. Make sure you use the negative sign, not the subtraction sign, which is what I just did. And then 1.375, because that was my T value, minus 4. And then the other part of the equation was T minus 3. So 1.375 minus 3. When I did that, I get 42.25. So that was Jace's height, 42.25. So then Jace's height was 42.25 feet. So Jace won on the height competition. He had the highest height. So that's that problem.